Okay, so let's review how to graph this particular function 4 sine of 3x. And then we're going to evaluate that particular function at some function values, these guys here. So the first thing we need to find here is the amplitude. The amplitude is easy to find. It's just the absolute value of 4, which is 4. And we're going to want to label that on our graph, the y equals 4 and y equals negative 4. So that's the maximum value and minimum value that that can take on. And the period, we've been doing very well with the period. The period is going to be 2 pi divided by the coefficient of that x term, in our case 2 pi over 3. So now that I know the amplitude and I know the period is 2/3 pi, and I also know that the constant multiplier on the sine is positive, so the graph is going to start at 0 and go to its max. Alrighty? So let's get a little extra room down here. And I'm just going to label some force here. I'm going to go out here and just do halves again. And we're going to want at least one period to the right of the y-axis and one period to the left of the y-axis. So I know the period is 2/3 pi, so this is 2/3 pi. Half of 2 apples is 1 apple, so this is going to be 1/3 pi. Half of 1/3 is 1/6, so this is 1/6 pi. And now someone asked me the other day, how do you find the third one? Well, you know what 1/4 of the period is. The 1/4 is 1/6, so you can just count 6. 1, 6, 2, 6, 3, 6. And 3, 6, you can label that 3, 6 or 1/2 pi. It really doesn't matter, just so it's correct. And then going in the opposite direction, I have negative 1/6 pi, negative 1/3 pi, negative 1/2 pi, and negative 2/3 pi. And I know it's a sine graph and it's going to start at 0, but before I do that, I'm going to label my, I'm going to label my minimum and maximum, and that's about right. I'm going to grab this guy and put him up there a little bit. There we go. And I know, because my amplitude is 4, that this line is going to be y is equal to 4, and this line is equal to y equals negative 4. It would be nice if you label that on the graph. You're not going to be taken off if you do. If you have the amplitude, and the lines, these lines are just an assistance in making a nice graph. So since this leading coefficient here, this is the guy that we're graphing this function, which is 4 sine of 3x, and since this 4 is positive, it's going to go to its maximum first. It's going to start 0, max 0, max 0, min 0, max, and it's going to go in the opposite direction to the left of the y-axis. So this is going to be min 0, max 0. And we're going to make a nice graph here. I'm not quite sure how nice I can do this in my smart notebook, but it didn't come out too awful bad. Much rather do this with pencil. And we know it goes on forever and ever. So I have my x-axis labeled with appropriate scaling. I have my y-axis labeled. And now I'm going to find a couple other points. This is something that we have not done before, but this is not, and this would help you with some multiple choice particular problems. So I want to find f of 7/3. I wonder if I can go down here. So what is f of 7/3? F of 7/3 pi. I'm going to put the 7/3 into for x, and this is going to be 4 sine of 3 times 7/3 pi. This is what I'm putting in, the 7/3. And for x, hey, what's 3 times 7/3? 3 times 7/3 is 7. So this is going to be the same as 4 times sine of 7 pi. Now I'm going to have to find the unit circle and determine what sine is at 7 pi. And it'll 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7. Sine of 7 pi is going to be 0. So this is also going to be 0 right there. Okay, and it's going to be that 7/3 pi is going to be way out here. It's going to be a 0. And that 7, I don't have the 7/3 pi labeled on the x-axis, but it's way to the right of that. All right, so let's find f of 5/4 pi as well. F of 5/4 pi, that's going to be 4 times the sine of 3 times 5/4 pi. 3 times 5/4 is 15/4, so little times here. So that's going to be 4 times the sine of 15/4 pi. And now I need to figure out where 15/4 is on the unit circle. I'm going to count around the unit circle. To be, and I realize that 15/4 is in the 3rd quadrant, and it's going to be negative square root of 2 over 2. So this is going to be 4 times negative square root of 2 over 2, which is going to equal negative 2 square root of 2. Okie dokie. So let's find those other 2 function values. The other 2 function values that we asked for. The next one was going to be f of 2/9 pi, negative 2/9 pi, which is going to be 4 times the sine of 3 times negative 2/9 pi. 3 times negative 2/9. 3 times negative 2/9, the 3's are cancel, is negative 2/3. So this is going to be 4 times the sine of negative 2/3 pi. Oh my goodness, that particular value is already on the graph, is it not? That particular negative 2/3 pi, well, be careful. No, that one is. Okay, so I'm not going to, this negative 2/3 is not the function value at negative 2/3. The actual function that we're looking at, this function 4 times sine of 3x, that's at negative 2/3 is 0. But here, I don't know what it is at negative 2/3, so I have to figure out what this rascal is. So I'm going to look at my unit circle and decide where negative 2/3 is. And where is negative 2/3? Well, 1/3, right here is negative 2/3. And the sine of negative 2/3 is negative square root of 3 over 2. So this is going to be 4 times negative square root of 3 over 2. And that's going to be negative 2 square root of 3. We have one more function value to find, and that last function value that we want to find is going to be f of 10/2 pi. 10/2. Oh no, I was reading the wrong problem. I apologize. So it's going to be negative 7/6 pi. What the heck is that going to be? That's going to be 4 times the sine of 3 times negative 7/6 pi. What is 3 times negative 7/6? This is going to be 4 times the sine of 3 times 7/6. The 3's cancel. That's going to be sine of negative 7/2 pi. So I'm going to look at my unit circle and figure out where, extend the page here a little bit, Lee, thank you. I need to figure out where what this value is right here. Okay, where is -7/2? So I notice that the sign of -7/2 is 1, so this is simply 4 times 1, which is equal to 4. So make sure you can find some function values. I think all of us can graph the functions correctly. I am going to review one of the homework graphs that we graded. Are there any questions about that, Mary Beth? Good deal. You got a good handle on that, Mary Beth? Bobby Joe? Jamal, thank you. So let's go back and look at this particular guy right here. Okay, so this is number 4 on the first assignment, graphing. We're going to find the amplitude of this function. The amplitude of that function is not -9. The amplitude is defined to be the absolute value of -9, which is 9. Amplitude is distance. Distance is positive. It's the distance from the x-axis. And all of us were able to find that the period is equal to 2 pi divided by 7. And so we're ready to sketch the graph of this rascal here. So let's do it. Here's my x-axis. Here's my y-axis. I'm going to split it up into fourths. Do another one if you want. Doesn't matter here. And I am going to get a maximum and minimum. I'll do them this time in yellow. And those two lines look fairly symmetric with respect to the x-axis, so I think that will do. And what I want to do first and foremost is label this y equals 9, and this is going to be y equals -9. And I'm going to label the period, which is 2 pi over 7. And I think we have a good understanding of how to label the increments on the x-axis. If the period is 2 pi over 7, half of 2/7 is 1/7, so this is going to be 1/7 pi. Half of 1/7 is 1/14 pi. And now I know what fourths are equal to. Well, 1, 4, 2, 4, 3, or 14ths, 1/14, 2/14, 3/14 pi. And going in the opposite direction, -1/14 pi, -1/7 pi. We definitely want to see the scaling of the x-axis and the scaling of the y-axis on the assessment. This is going to be 3/14 pi, and this is -2/7 pi. What we need to be careful here is that since this multiplier of the constant trig ratio is negative, this rascal is going to start off at a minimum value. Oh, I don't know how I would be able to figure that out. Well, if you don't know whether they start at the cosine starts at the minimum or maximum, hey, just put 0 into the function. And so let's just evaluate the function at 0. And the function at 0 is going to be -9 times the cosine of 7 times 0. 7 times 0 is 0, so this is going to be -9 times the cosine of 0. And I know from my unit circle that the cosine of 0 is 1, and -9 times 1 is -9. So you know this rascal has to start at its minimum value. And so if the cosine, and we know what the graph is going to look like. It's going to start at a minimum, 0, maximum, 0, minimum, back to 0. And if I'm starting here at minimum, going the opposite direction, Going to the left, it's going to be 0, max, 0, min. It's going to keep going, but let's sketch our nice little, some people have been putting V's there. If you could please not put the V's, I would appreciate it. Let's see here. And that's a very nice graph. And some people had the incorrect graph there. They had it started at the maximum level. Okay. Let's solve. So I've got some answers here. Let's check these. I'm not guaranteeing that these are all correct. So are they all correct? All right, very good.